Today we are going to take everything we've done in 8.1 through 8.4 and kind of sum it up in here solving rational equations. And so the first thing I want to talk about is if you have an example like A, where you have x over x minus 6 equal to 15 over x minus 4. So if you have a single fraction on each side, solve it as a proportion. In the case of you guys, you will probably cross multiply. So we have this times this equals this times this, which means we have 15 times x minus 6 equal to x times x minus 4. And then you can go ahead and solve it as you would for x. So 15 times x is 15x. 15 times negative 6 is 90. X times x is x squared minus 4x. Being that we have a squared in there, we want to make sure that we get everything all over to one side. So I'm going to go ahead and subtract 15x from both sides and add 90 to both sides. This gives me, scroll this up for you, we get 0 equal to x squared minus 19x plus 90, which means I need two numbers that multiply to 90 and add to negative 19. And so I know that that means I have 10 and negative 10 and negative 9. So I have x minus 10 and x minus 9. So I go ahead and I see that that means that x can equal 10 or 9. Now the last piece, I'm going to skip ahead a bunch of these steps because this has to do with examples B, C, and D. Yes, it's a long process. The last piece is to check for extraneous solutions. And what we mean is if we go back to our original problem, and if either of the answers, or if any of the answers we get fall into our domain restrictions, then that means that they are extraneous and not actually a solution. In our case, our extraneous solutions say that x cannot equal 6 or 4, so we are good to go. Now, if we get something like we have in example B, then we're going to follow on, in that case, to step 3. So what it says here is the first thing we're going to do is if it's subtraction, we're going to change to addition by distributing the negative through the second numerator. And so I look here, and yep, we can probably go ahead and say this is really adding a negative 4, but it's more if you have binomials. Step 4 then is going to be to factor all the denominators possible, which we have everything factored that we possibly can. And then we're going to multiply every term by a common denominator over 1. So if I look here, this is really negative 4 over 1, this is really 3 over 1. My common denominator is x times 1, which is x, which means I'm going to go ahead and take 15 over x, and I'm going to multiply that by x over 1. And then we have plus negative 4 over 1, and I'm going to multiply that by x over 1. And that is equal to 6 over x, and I'm going to multiply that by x over 1. And finally we have the plus 3 over 1, which we will multiply by x over 1. The reason why we want to do this is because I see here that these x's will cancel, as will these x's. What has now happened is we've put 1's all the way across the denominators, clearing that denominator. So now that we've done that, I can go ahead on to step 6, which is to cancel each individual denominator, which we just did. And step 7 is to multiply the leftover numerator stuff. Here, all I see I have left, I'm going to circle what I've got left to make my life easier. So I see that I've got 15 minus 4x is equal to 6 plus 3x. So then I can go ahead and solve. I'm going to add 4x to both sides. And I'm going to subtract 6 from both sides. Doing that will give me 9 is equal to 7x. Divide by 7, and we get x equals 9 over 7, or 1 2/7. When I go back up to the top, I see that my only restriction is that x cannot equal 0. Therefore, because this is not equal to 0, we are good to go. Moving on to example C. We have here, forgetting about step 8, which of course is to solve the remaining equation according to degree, which you've seen. Here, in this problem, I see that I have x's and 3's. So that means my least common denominator is 3x. So I'm going to multiply by 3x to every term. And you can put it over 1 if you want. Now that we've done this for a little bit, I'm going to say no. And so that cancels this 3x and this 3x. It cancels the 3's and it cancels the x's here. Which then what I have left over is 3 times 1, which is 3, plus 1 times x, which is x, which equals 8. Subtract 3 from both sides, and I get x equals 5. And in my original problem, my domain restriction was x could not equal 0. So we are in the clear. Finally, a little bit more difficult of a problem. First thing we need to do is factor. And I see that x squared minus 9 factors to x minus 3 times x plus 3. And when I do that, I'm going to cross this off so I don't get confused. I see that I have x plus 3 and x minus 3 in every single that we need for a common denominator. So what I'm going to do is I'm first going to write x over x minus 3, and we'll leave some space in between these. 2x over x plus 3, and that is equal to 18 over x plus 3, x minus 3. So I'm going to multiply by my LCD, which is x plus 3, x minus 3, to every single term. And then I can start canceling. So I see here that these cancel with these, the x plus 3's cancel here, and the x minus 3's cancel here, which means that I have x times x plus 3 plus 2x times x minus 3 is equal to 18. So then I can go ahead and start foiling this out, which means I have x squared plus 3x plus 2x squared minus 6x equal to 18. So then I can combine my like terms, and when I combine my like terms, I get 3x squared minus 3x, and then I'm going to bring my 18 over here, so minus 18, and that's equal to 0. Then I see that I have a common denominator. So I'm going to factor that 3 out, leaving me with x squared minus x minus 6 equal to 0. That means I need two numbers that multiply to negative 6 and add to negative 1, which means I have negative 3 and positive 2. So I can factor this. Now I've got 3 equals x minus 3 times x plus 2 equal to 0, which means that x can be equal 3 or negative 2. However, if we go back up to check for extraneous solutions, I see that x cannot equal 3 or negative 3 because of what's in my denominators. Therefore, because 3 is in here, this is an extraneous solution. So therefore, it is not part of what we're looking for. Your job now is to go ahead and solve these two U-try problems. Bring your questions with you to class tomorrow.